Hi, everyone. I wanted to take a moment to introduce a couple other function blocks that will be, some will be needful and some are just useful for our capstone project. So again, this is using the Micro850 motion control system. And here last time we talked about the MC power function block, the MC reset, the MC move relative, and the MC read parameter. So today I'm going to just highlight a few things on those as well, but I'm going to introduce also the MC move velocity, the MC stop, and the MC read status. All of these are very useful tools to have as part of your motion profile and motion program. So MC power, as we discussed before, is what enables power, brings power to the stepper drive. And so it allows your access to function. And so we do that by setting this one enabled bit as true. I have mine tied to this variable stepper on. And then there's also these other two variables that are important, stepper forward as well as stepper backward. And that is to isolate the motion in one direction or the other. Now, one point to understand with that is if you toggle either of the state of those, forward or backward, you also have to toggle the enable bit from on to off and then back to on in order to be able to recognize these two. Otherwise, it doesn't recognize the change in state. For this case, since we're really utilizing it in both directions, we can go ahead and just select both of these as being true for being on. Okay. The MC reset we discussed, MC relative move relative. We also discussed, you can see here where I've tied mine into some variables. You can also write the value directly in to these function block inputs if you don't want to tie it into a variable. I like having it represented as a variable because then it allows me to make changes inside the program as needed. Okay. This other one is the read parameter, which we discussed last time, allows you, and for this particular case, I am using it to read the position of the motor. So now the motor doesn't have an encoder on it, so we're not getting that position feedback from the motor. It's just the motion control engine of the software is keeping track of the number of steps, either in the positive direction or the negative direction, and then reading that back as a numerical value that helps us to keep track of the motor's position. All right, the other one that I wanted to show was this move velocity. So the move velocity function block allows us to move the axis in just one direction or the other at a constant velocity, meaning that it's going to ramp up to a velocity and then it'll just maintain that velocity until we tell it to stop. So it's not really driven by any positional offset, just by that velocity and stop command. The stop we get from this MC stop function block. And so it is a function block that will override anything else that if for whatever reason, say in our capstone, we push the stop button and we have that tied into this function block, it would initiate the stop of whatever motion is taking place. And so it'll override that and stop the axis in wherever it is at and bring it to a stop. So let's go back and look at this move velocity one real quick. So again, just as our inputs, we select what's axis we had set up. So in my case, I named mine stepper. And then here in our execute bit for input, we would have something tied into it that allows us to, some variable that would be tied into it that allows us to toggle that on or off, true or false, that then would execute the function of this block. The velocity, acceleration, deceleration, and jerk, I just tied into, again, another set of variables that had those numerical values associated with them. Here in the direction, this is a single integer that allows us to change the direction of the velocity. It recognizes a negative one, a 0, or a positive one. So the positive one, again, would take it in a positive direction. A negative one would take it in a negative direction. 0 actually maintains whatever direction was last utilized. So if we had been going in a positive direction and then we initiated this function block, it would continue to go in a positive direction, as well as if it had been going in a negative direction and then this was in this function block for the move velocity, we had this selected as 0, it would continue to go in the negative direction once it was executed. With the velocity value of this function block, it takes this direction value and multiplies it to this velocity value. So if our velocity value is a negative, this direction value is a negative, it'll result in a positive velocity. So then our velocity would be in the positive direction, even though we have a negative here in selected for the direction. So it's just important to realize how that's utilized, and that this directional value is multiplied by the velocity value, and the combination of which really dictates the velocity and the direction of that velocity. So in my case, I just leave this as a positive value, my velocity, and then I'm using the direction in order to control it as a positive or negative direction. But you can really decide how you want to handle that, what makes sense in your logic. All right, now let's go down to the stop, this stop function block. So here in the stop function block, a couple things that we need to configure is, again, the axis that we're utilizing. So here I'm utilizing the stepper axis. And then I'm also using the stepper, or this variable stepper stop execute as a way to initiate the function of this function block. And then we can also put in labels here or directly input numbers for deceleration and our jerk for stopping the axis. Okay. So let's just go ahead and show that real quick. So if I go here to this is my local variables list where I have all those function blocks. And so we go, let's scroll back up here a bit. And so I've already got my MC power is both the forward and backward are enabled. And then I've got my on enabled, or the enable bit on. And so we can see that it's both active and it has a true status. So now let's go down to our read parameter. And so in my read parameter, this will just allow us to watch what happens with the with this value here of the position of the axis, which I have tied into this variable stepper position. And so that would be the same thing as what we would read inside that function block, the read parameter function block. Okay, now let's go down here to our velocity execute. So in my velocity function block, let's go back here to the left. I have it tied into this variable stepper velocity execute, which is right here. So if by selecting that, we should see this value start to go in a negative direction. Again, I've got a positive velocity, but a negative direction. So by multiplying those two together, I get a negative magnitude in my velocity. And so we can see that here by this value is going, and the stepper position value is going in a negative direction. And it'll, again, continue to do so until I select or initiate this MC stop or this stepper stop execute. So let's just go ahead and do that. Okay, so that went ahead and turn that off since that's a rising edge. So as we can see, that stopped the velocity there. And if, say if we were using that as a way to home, we could then move until it, move the axis backwards until it read the sensor. And then that's, as getting that sensor position, it would trigger that stop function, which would then would initiate this MC stop function block, stopping our velocity. This read status function block is another one that is quite helpful. I have this one as far as enabled by just whenever the system comes on, this becomes automatically enabled. This one is nice for two values that I like to monitor. Both is looking to see if it's in standstill mode and also if it's for in error stop mode. Sometimes there are a lot of cases when we want to know is the motor okay to run or if it's in an error stop. And so then we can be alerted that there's something wrong and we can try to reset it. So it's not always clear from just the other function blocks that we use that it's in an error state, especially when we lose that the execute or the enable bit that causes or initiates or causes that function block to commence. And a lot of times when we lose that signal, the error also goes away. But by monitoring this read status, we can also see if there is an error or if it's in an error state. Okay. Hopefully that helps. It gives you a little bit more to play with in terms of the in terms of using the axis and some of the other function blocks. Next time I'll cover a little bit more on the or I'll cover the homing sequence and how to utilize that, and also the absolute move sequence. And so give you a little bit, give you some other options to use as you're moving your axis back and forth.